The sports science today, we're decoding the math behind a volley.
After analyzing the footage here at Sports Science, we determined that in order to obtain the perfect volley, a number of factors must be met. To further explain these topics, we've brought in an expert.
So the equation of this is y equals -3 cosine pi over 9 times x minus 1 plus 3 and 2/3. The a of this graph is -3 because the amplitude of this graph is 3, and the negative is there because the ball increases before it decreases. The b value of this equation is pi over 9 because to find the period, which is 18 yards, you have to divide 2 pi over 18, which is pi over 9. The c value is x minus 1 because the graph moves 1 to the right. Amplitude, which is 3 yards, is the distance above and below the center line of the graph. And the period of this graph is 18 yards, which is the total distance the ball travels. The phase shift explains that the ball is kicked 1 yard away from the player because his leg extends to 1 yard. The d value of this equation is 3 and 2/3 because that's the vertical shift of the graph. The vertical shift, which is 3 and 2/3 of a yard, shows the maximum height the ball reaches plus the lowest the ball goes divided by 2. The domain, which in this case is the distance the ball traveled horizontally, was from 1 to 19 yards. So the range in this case, which is the distance the ball traveled vertically, was from 2/3 of a yard to 6 and 2/3 of a yard. The minimum of this graph, which is 2/3 of a yard, is when the ball is initially kicked to when the ball enters the goal. The maximum, which is 6 and 2/3 of a yard, is the highest point on the graph and shows the highest the ball goes.